In this video, which is jumping all the way to Chapter 5, Lesson 5, we're going to look at a different type of proof, which is called proof by contradiction. In this sort of idea, you think about all the possibilities that could happen. You know that one of them has to be true. If you can rule out all the other possibilities, you use some indirect reasoning to say, well, that means the last one, the remaining one, must be true. And so that's basically the steps that we would look at here. In the way we do this proof, we basically say, let's assume the opposite of what we want to have happen is true. And then we show that through some logical steps that in the end, all of a sudden, something occurs that is not possible. And if it's not possible, that means that what you started with, the original assumption, is not true. And so that means that if that's not true, the opposite must be true, and in a kind of an indirect way, you've proven what you want to prove. So let's just kind of run through a few examples and show you what that kind of means. In our first example, we're just trying to show that the square root of 50 does not equal 7. So you might start off this proof just by stating your option. So you might say, well, either the square root of 50 equals 7, or the square root of 50, sorry, I said does not equal 7, or you would say square root of 50 equals 7. It's got to be one or the other, okay? So either one of those is true. You're not really sure what is, but one of those two would have to be true. And so if we're trying to show that it does not equal 7, we're going to assume the opposite. So that's kind of listing our options. Maybe we would say then, well, let's assume that the square root of 50 equals 7. Okay? Then we could say, well, then the square root of 50, if I squared that, it should still equal 7 squared. Okay, well, what's going to happen if we square those values? Okay, well, we say, so square root of 50 squared is just 50. 50 would equal 7 squared, which is 49. That cannot possibly happen. Okay, so that's our contradiction. So you might kind of summarize this then by saying, this, sorry, I shouldn't have picked red again. This can't be true. So our original assumption is false. Therefore, the square root of 50 does not equal 7. Okay, the original one was false, where we said they were equal. The only other option is that they're not equal. So we have kind of in an indirect way proven that that cannot be true. Okay, example 2. Again, maybe something that we're somewhat familiar with, but use an indirect proof to show that a triangle cannot have two right angles. So for this one, maybe you would say, maybe we would just draw a triangle to start off. It can be any sort of triangle. We'll label it A, B, and C. You could again go through and say, well, either a triangle has two right angles or it does not. Those are our two options. We're trying to say that it cannot, so we're going to assume the opposite. So let's assume that this triangle does. So I'm not going to write out everything, all the options like I did on the first one. So let's assume triangle ABC has two right angles. Let's say it's angle A and angle B. Okay, so that's kind of our assumption. So what can we say from that? Well, we know that in a triangle, the measure of angle A plus the measure of angle B plus the measure of angle C has to equal something. What's that going to equal? It's got to equal 180 degrees. And if we have two right angles already, and we've kind of named them, We could say, well, so 90 plus 90 plus the measure of angle C has to equal 180. And if I put the two 90s together, I get 180, and I bring that to the other side, that's going to lead to something kind of funny. So let's see, how could we phrase it then? So 90 plus measure of angle C equals 180, and the measure of angle C would have to be 0. Okay, that's our issue. So this can't happen. Therefore, a triangle can't have two right angles. Okay, again, we assumed that it could. We saw that that was an issue. So the opposite has to be true. It can't have two right angles. So again, just a couple quick examples here of how we might format some sort of an indirect proof.